Hi guys, today we are learning Geometry 10.4 Inscribed Angles. You guys will be able to find measures of inscribed angles and find measures of angles of inscribed polygons. So first of all, we have some vocab. An inscribed angle has a vertex on a circle and sides that contain chords of the circle. In circle C, we have angle QRS is the inscribed angle. So this angle, QRS, has a vertex on the side of the circle. This is different than our central angle that we saw last week. Our central angle has our center at the center of the circle. They have slightly different theorems as well, which we will see in a little bit here. An intercepted arc has endpoints on the sides of an inscribed angle and lies in the interior of that inscribed angle. So we have our inscribed angle here. Let's get back to it. This arc QS is our intercepted arc. And that's what it says here. Specifically intercepted by that angle. There are actually three ways that you can draw an inscribed angle in a circle. Center P can be on one of your sides of your inscribed angle. Center P can be inside your inscribed angle, or P can be outside your inscribed angle. We have a theorem here. We have the inscribed angle theorem. It says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So I'm just going to make up some random numbers. If this angle is 30 degrees, the intercepted arc has to be double that. It is 60. Okay, this is different than our central angle last week that we saw. If this was 30, the central angle, then our arc was 30. Okay, so this is central angle, which is different than our inscribed angle. And this is what we are looking at specifically today. So we're going to do a proof really quick. Angle B is inscribed in circle P. It wants us to find that angle B is half the measure of this arc. So let's just follow through. It says draw an auxiliary radius PC. That's just an extra thing here. Looks like we forgot to write in the given. Let's do step 0. Let's do that first. Angle B, that's my bad guys. Angle B is inscribed in circle P, which step 0 is given. Okay, now we can draw that auxiliary radius, PC. You can do that anytime you want. 2 points determine a line. It's not always helpful, but in this case it is. We know that segments BP and PC are congruent because every radius in a circle has to be congruent. Triangle PBC is isosceles because those sides are congruent. So the measure of angle B and the measure of angle C are equal. Probably should have said that a little bit differently, but those are the ones we're talking about. This is by the isosceles triangle theorem. We then know the measure of angle APC is equal to the addition of these two. APC, guys, is this angle here. That has to be a 90 by exterior angle theorem, which we learned a long time ago. We know that the two remote interior angles equal this exterior angle. So these two add to equal this. We then can replace this in here with the measure of angle B because they are congruent to each other. So we use substitution. It's a weird substitution. It's a little different than what it looks like in Algebra 1. But we're doing substitution, substituting this in for this. So that's with steps 4 and 5. Step 7, we know that the measure of measure of arc AC is equal to the measure of this angle by that central angle theorem. I guess I have written down here definition of arc measure. And then I can do substitution again. Since I know this is equal to this, I can replace measure of angle APC with 2 times the measure of angle B. So that's how I get to this. So this is specifically substitution, but this time with steps 6 and 7. Now, I can just flip-flop these. Technically, this is not the same as this. It's a little weird to think about, so I just have flip-flopped them here. That's called our symmetric property of equality. And now I have one division step here. If I divide by 2, I get to this. So we have our division property of equality. It's called that because you're going across the equal sign. And that is actually what it wants us to prove. That the measure of our inscribed angle is half of our arc measure. So we're good here. Now that we've proved this theorem, we can use it. So that's what we're going to do. And guys, I'm going to give you a heads up. There is a test question like this. So make sure you're really paying attention. Make sure you really understand. If you don't, ask me. First of all, we are finding the measure of angle X. I notice that this arc here has the same endpoints as that inscribed angle. So this angle has to be half of the arc. So I just divide by 2 to get the measure of angle X. The next one, we are trying to find our intercepted arc. So notice I'm trying to find YX. My intercepted arc is double the measure of my inscribed angle. So I just multiply that by 2. And I get 105 for the measure of my arc. Pause me. Try this, you try. Okay. Angle C is my inscribed angle, and it is related to this intercepted arc. So to find C, I just have to divide 94 by 2. I get 47 degrees for my measure of angle C. So remember, guys, this is different than central angle. Central angle is exactly equal. Inscribed angle is half of your arc. Or in this next case, your arc is double your inscribed angle. So we're going to take 48 times 2. That gives us 96 degrees for the measure of arc BC. Okay, we have another theorem. This tells us if 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So this might be a little bit difficult to visualize, but notice both of these angles, inscribed angles, have the same endpoints, right? This inscribed angle has an endpoint of A and D, and this inscribed angle has the same 2 endpoints, which means since they're both related to this arc, say this arc is 50, these angles both have to be half of that. And once again, I just made up that number. I didn't find 50 or 25 anywhere. That's just how they're related, okay? That means also that those 2 angles have to be congruent to each other. In this case, they're both 25. So if I'm trying to find the measure of angle R, I notice angle R is this inscribed angle, which happens to be related to this inscribed angle. Now notice we don't know what this arc is, so we're not going to use that. But since they are both related to that intercepted arc, that means these two angles have to be congruent. So I don't even have to know what the arc is to do this problem. Since I know those are congruent, we will simply set these equal to each other. So I add 13 to both sides. I subtract 9x on both sides. I get 3x is 15. So x is 5. That's not my final answer though. I do have to plug this back in because it is asking me for angle R. So angle R is 12 times 5 minus 13, or 20 minus 13, which is 47 degrees for the measure of angle R. We also know angle S has to be equal to that because they are congruent. All right, go ahead and pause, find angle I. Alrighty, before we do that, I want you to know that there is one test question like this as well. So if you are confused, make sure to ask me. You are going to have to find the actual angles, not just the value of x or y or whatever variable, okay? So notice for this one, we have two inscribed angles again. We've got angle I and we've got angle J. And they have these same endpoints, both G and H. So they are related to this same arc here, which means these have to be congruent to each other. So we're going to set them equal again. So we have 10x minus 1. Sorry, my computer's being glitchy. We have 10x minus 1 equals 8x plus 9. I'm going to add 1 to both sides and subtract 8x on both sides. And it looks like we actually end up getting that x is 5, again, like the last problem. But when we plug this in, we need to find the measure of angle I. I'm guessing it's going to give us a slightly different answer. So we get that the measure of angle I is 49 degrees. So make sure you're prepared for a two-part test question like this question. When you are ready, flip your page. We have a proof here. We're going to use our inscribed angles in our proof. We're going to write a 2-column proof. Always start with your given. Even though I accidentally didn't do that on the last one, we fixed it. We have arc LO is congruent to arc MN. We are trying to prove triangle MNP is congruent to triangle LOP. So I can mark what I know. I know arc LO is congruent to arc MN. That guarantees me, we learned this recently, that these chords with those endpoints are also congruent. It's kind of a long explanation here. It says if minor arcs are congruent, their corresponding chords are congruent. And I promise we did learn that. So we know these are congruent. There's actually a test question that uses that idea as well, that those chords have to be congruent. I'm going to get rid of that. Oh, actually, no, let me keep those because we're going to use this, I believe. Okay. Next, we're going to look at something else. We're going to look at angle N and intercepts arc ML, and same step, angle O intercepts that same arc. So this is kind of what we were just looking at. We're going to eventually get to the fact that those are congruent to each other. So step 3, angle N intercepts arc LM. Angle O also intercepts arc LM. This is just the definition of an intercepted arc. So because of that, I know that these two angles, angle O and angle N, are congruent. We can say inscribed angles of same arc are congruent. Next, I can state that these two angles are congruent because of vertical angles theorem. So I can say angle MPN is congruent to angle LPO by vertical angles theorem, which means we can now state our triangles congruent like it asks us to. MNP is congruent to triangle LOP because of angle, side. And we're good to go here. You're not going to have to do a proof on your test. This is just keeping them in your memory so that way you still know how to do them, working through the steps, and also reminding us of some of our theorems from our previous couple sections. Next, triangles and quadrilaterals that are inscribed in circles have special properties. An inscribed angle of a triangle intersects a diameter or semicircle if and only if its angle is a right angle. So we actually used this on one of our previous lessons, and I told you we'd get here. This has to be a right angle because it intersects this diameter. Remember, this is technically an inscribed angle, which means this arc here is 180, and half of 180 is 90. So this has to be a right angle if it intersects a diameter. So on our next page, we're going to use this fact. We are going to find the measure of angle B. So I know, since this is a diameter here, that this angle has to be 90. So I'm just going to take 90 plus x plus 4 plus 8x minus 4, and I'm going to equal that to 180 because this is a triangle here. That's going to be my best option. So I combine like terms, I get 9x plus 90 because when I combine the 4 and negative 4, they cancel out. Subtract 90 on both sides. So 9x is 90. So x is 10. Once again, that is not what it asks for. It asks for angle B. Angle A and B are not congruent this time, so you do have to specifically plug it in here. And you should get that angle B is 76 degrees. Pause me. Try this. You try. All right, let's do it. We once again know angle F has to be 90 because it is an inscribed angle with endpoints at the diameter. So we'll take 90 plus 2x plus 6 plus 8x plus 4 has to equal 180 since this is a triangle. So we combine like terms, we get 100 plus 10x equals 180. Subtract 100 on both sides. 10x is 80. So x is 8. We are finding angle D, so we do have to plug it in specifically to that angle. So we get 16 plus 6, which is 22 degrees for the measure of angle D. Okay, we have another theorem says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Remember, quadrilateral, that means four-sided shape. Inscribed means it's inside the circle. And supplementary mean they add to equal 180 degrees. So those are all old vocab words. Basically, it's saying that angle K plus angle M has to equal 180, and angle N plus angle L has to equal 180. This has to do with our inscribed angle situation. If we think about this, we know that this angle has this intercepted arc, and we know this angle has this intercepted arc. So they work together, their intercepted arcs, to make the full circle. And since our angles are half of the arc, that means these are supplementary. So I first have to find angle S. So if I know angle V is 90, angle S has to be 180 minus 90. That one's kind of a freebie. That's fairly easy here because there's no actual math here. Next one, U and T work the same way. They are supplementary. These two angles are. They have to be because their intercepted arcs work together to form the whole circle. So to solve for this one, all I have to do is add these two angles together and equal them to 180. So I get 22x plus 4 is 180. So 22x is 176. So x is 8. That's not the final answer though. We want angle T. So we have to plug it back into here. So 8 times 8 plus 4, or 68 in total, is the measure of angle T. While you guys try the U-try, I'm going to let you know that there is one on the test like this as well. So at this point, we've gone through examples of all the ones that you'll see on the test, and hopefully that helps you know what to study. Okay, if you haven't paused me, do it now. We're going to go through finding angle N. So we have that new theorem that tells us that our opposite angles in our quadrilateral that are inscribed in a circle specifically, if they're just random, this isn't true. It has to be inscribed in a circle. These are supplementary. So, since I'm finding angle N and I'm given angle L, they are opposite from each other, so I can go ahead and add these together and equal them to 180. So I get 14x plus 12 is 180. Subtract 12 on both sides. 14x is 168. Divide by 14. So x is 12. Not my final answer though. Gotta plug it back in for n. So we take 3 times 12 plus 12. So our final answer is 48 degrees for the measure of angle N. Okay, let me know if you guys have questions. Otherwise, you can work on any old deltas or flip your page and work on a worksheet in the packet. Have a great day.